along with my teammate, Parth Patel. We are Group 3 presenting our final project for CS7319. Our project is the AI Resume Analyzer System, a web application that uses artificial intelligence to evaluate resumes against job descriptions and provide structured, actionable feedback. Um, for the project description, the project we set out to solve is straightforward. Job seekers submit resumes without receiving meaningful feedback before applying. Most assisting tools are either fully manual or completely obscure, so giving a score with no explanation. Our solution is a web-based AI resume analyzer that accepts resume text and job description, runs it through an analyze pipeline, and returns a score from 0 to 100, keyword gap analysis, and plain text improvement suggestions, all powered by Claude API from Anthropic. Results are also persistent to a PostgreSQL database. So we'll go over the first architecture here. So this is the layer monolithic. The layered architecture organizes the system into 6 strict horizontal layers at the top. The React frontend collects resume input from our user and displays the results. Below that, the resume controller handles incoming HTTP requests and routes them to the service layer. The server layer contains 2 components: resume service, which orchestrates the overall workflow, and rule-based scoring engine, which delegates to our AI integration. The AI layer contains Anthropic service, which calls the Claude API over HTTPS. The data layer holds both JPA repositories, and at the bottom, PostgreSQL persists all results. The critical rule of this architecture is that each layer only communicates with the layer directly below it, no layer skipping. So next slide. So here are the implementing classes. Resume evaluation result are our plain domain models with no upward dependencies. Resume controller depends on iResume service, the interface, not the concrete implementation, which gives us decoupling. Resume service implements iResume service, and coordinates the full workflow. Rule-based scoring engine calls Anthropic service, which can see in the bottom right with the 4 methods analyze, build prompt, parse result, and fallback result. The repositories at the bottom handle all database operations, through Spring Data JPA. Next slide. So component to class mapping. This table maps each architecture component to its implementing class. Every component in the proposal maps directly to 1 or 2 classes. The domain model of resume and evaluation results sit at the base with no upward dependencies. Anthropic service is the only class that crosses what you might consider a layer boundary. It lives in the service layer, but calls an external API. This design choice was to keep testable and swappable. So this is the pipe and filter architecture. This is actually the architecture we changed from the original proposal, and I'll explain the rationale later. But this is also the selected architecture. And filter architecture replaces horizontal layers with a sequential filter chain. The request still enters through the React front end and passes through resume controller and resume service, but instead of calling a service layer directly, resume service hands off to the resume pipeline, which you can see here as the coordinator. Resume pipeline executes 4 filters in order. Validation filter checks that the resume and job description are not empty. Text extraction filter cleans and normalizes the text. The AI scoring filter sends the data to Claude API, and the persistence filter saves the results to PostgreSQL. The key concept here is the resume payload, a shared data object that travels through every filter, getting enriched at each stage. Again. The class diagram reflects the filter pattern. Filter is the Java interface with a single method. process taking a resume payload and returning a resume payload. Every filter implements this contract resume pipeline, assembles the filter chain and loops through it. Resume payload carries all the data, um, and then the data is clean context, keyword score, feedback, and the final evaluation result. The four filter classes each implement filter with their own process method. Anthropic service sits at the bottom right, as you can see, identical in the both architectures, handling all the Claude API communication. And for the component to class mapping, the mapping for the pipeline and the filter architecture is something larger, 12 classes versus 9 in the layer architecture. 3 classes are unique to this architecture, which is filter, the interface, which defines the pipeline contract, and resume pipeline, the coordinator, and resume payload, the data carrier. Every filter maps to exactly one class, making responsibilities very clear. And the Anthropic service is shared between both architectures, though implemented separately in each project. I can take over.
Yeah. So um, both the architectural compare both the architecture styles. So here is the side by side against our quality attributes, starting with performance. So both the architecture uses synchronous calls, so neither has a significant advantage here. Both the architecture latency is around 10,500 milliseconds in our testing. And for scalability, let's take an example that if 100 users submit their resumes concurrently, the layer monolithic must replicate the entire Spring Boot application just to handle the extra AI scoring load. Whereas in pipe and filter, we could scale only the AI scoring filter independently. So it is comparatively easier to handle the scalability in pipe and filter architecture just because we just need to add one more filter on top of that. And for the modifiability, let's since that is like for modifiability, here is a like a concrete example. Let's say we want to add a grammar checking feature. So in that case, in layer monolithic architecture, we have to modify resume service, which is already being handled, and AI scoring and persistence, touching existing tested code and risking regression. While in pipe and filter method, let's say if we want to add a grammar checking feature, so in pipe and filter, we simply create a new grammar check filter class, implement the filter interface, and add it to the pipeline. So here zero changes. There is no changes in other filters such as validation filter, text extraction filter, or any existing code. So in modifiability, the here is also pipe and filter performs better as compared to the layer monolithic. And for let's say fault isolation, if let's take an example where in layer monolithic, if the Anthropic API service throws an exception in layer backend, the entire request fails with the 500 error code. Whereas in pipe and filter, the validation filter catches the failure and stops the pipeline gracefully with a meaningful message. So end of the day, it's the in pipe and filter, it's just show the zero as a score rather than showing any error. So it's also performing better over here. In case of debugging, it is in layer monolithic architecture, it is comparatively easy to trace the code, and it's an explicit call stack. Whereas in a pipe and filter, it has a clear logs and sequential as well as traceable of each operation that is being being run on the pipe and filter side. So here, reusability in layer and monolithic is all the layer as our final architecture. So here are the few reasons of our selection. So first would be maintainability. So each filter has exactly one responsibility, like a validation filter only validates, AI scoring filter only scores, and like changes to the one filter never affect others. So it's easy to modify any changes to the pipe and filter architecture. And secondly, first would be the maintainability. Second is modifiability. This is the strongest argument. Adding a grammar checker, for example, requires only implementing the filter interface and adding it to the pipeline. We demonstrated this during the development when adding a text extraction filter requires zero changes to any existing filter. Third would be debuggability. Our real timing data shows exactly how long each filter takes. Like a validation takes 5 milliseconds. Text extraction takes almost 10 milliseconds, and AI scoring takes 10 and almost 10,000 milliseconds. So here persistence and a persistence almost take a 50 milliseconds. So this per filter visibility is a direct advantage. Fourth would be the performance. So here both the architectures average around 10,500 milliseconds in latency. So it's take that much amount of time to filter each and every, like evaluate each and every resume. And the bottleneck here is the Claude AI call, not the architecture itself. So and the last comes with risk, and we identified them formally using the lightweight architecture evaluation method, and on based on atom atom method. For the layer monolithic, we identify two high risks. First would be tight coupling, like changes in the service layer can unintentionally cascade cascade to the controller. Second would be hard scoring. We cannot scale AI scoring independently from the rest of the application. We also identified a medium risk around layer bypass temptation, where developers under time pressure might skip layer and violates the architecture. And for pipe and filter, there are few risks also. So like, is the pipeline bottleneck? First of all, is the pipeline bottleneck, since filters execute sequentially, slow AI scoring filter blocks all downstream filters. And the second risk would be is a partial data loss. If a filter fails mid pipeline, any intermediate analysis that has not been persisted yet could be lost. We also identified payload blot as a medium risk, and the resume payload object will grow as a new filter and are added over time. Importantly, the pipe and filter risks are either unavoidable or manageable, while the layer risk directly threaten our business goals. So here the risk analysis, empirical evidence. So let's look at the real data we collected. So we tested 5 different resumes against the same job description on both architectures. The average API response time was 10,750 milliseconds for layer and 10,550 milliseconds for pipe and filter. Both architecture fail our non-functional requirement one target of 3 seconds, and this is a critical finding. The bottleneck is the Claude AI call, not the architecture. So our per filter breakdown confirm this, that much more amount of time is being taken by the AI to evaluate the resume, not the any other, not any other features. And for code metrics, layer has 9 classes and around 620 lines of code, while pipe and filter has 12 classes and 780 lines 80 lines of code. With extra classes are filter interface, resume pipeline, resume payload, and the fourth filter implementations. For failure handling, a layer returns a simply 500 error code, whereas if any point in time, if time and pipe and filter fails, it returns zero as a score. So it handles error in that way. And run it by just and
Yeah.
okay. So here is the our homepage for the architecture. There are mainly three functionalities over here. Analyzer, where we need to provide the resume, text of resume, and the job description. And in history, you can get the history of your evaluation of the resume. And here is the architecture where we are storing the latency waterfall. Essentially, the time is being taken by the system to evaluate each resume. So let's analyze the resume in a layer monolithic. Here we can switch the architecture pattern. Now right now pass the job description and a resume. The AI will start evaluating resume and give us the feedback necessary feedbacks. So here we can see that this number of so basically evaluation is showing the keywords that are present on the resume and also showing the missing keywords that we need to add in our resume. And apart from this is it is also showing the few suggestions like you must add experience with the AI coding which was present in the job description but not present in the resume. So here are the few improvements which can basically helps to pass the ATS screening. So the final score is the 52 out of 100. It's basically a D grade. So let's evaluate the same resume and same job description with the pipe and filter method. So here we can see that it is also showing the same thing. 12 keywords are being 22 keywords are present and 12 keywords that are missing from the resume. And it is also suggesting a few it is also providing few suggestions which we need to add in resume. So in history we can essentially see the resumes that are being evaluated by the AI, evaluated by the project. And here is the architecture of both a layer monolithic and pipe and filter. And we can see the latency waterfall here that monolithic take nearly this amount of time and pipe and filter take nearly 10,000 milliseconds. So here is the